how to graph the equation involving sine or cosine function using the unit circle like this. Okay, so what we're going to do, instead of using the increments 1, 2, 3 like that, increments of 1 unit, we go to the most convenient increment, which is the pi. Right, so let's begin from uh, pi, and this is 2 pi and 3 pi, and you can continue, and we can divide this more into pi over 2, half of it, and next is 3 pi over 2, and then 2 pi and 1/2, that is 5 pi over 2, and then this one 3 and 1/2 pi, that is 6/7 pi over 2. Okay, and to the negative, this is our x-axis, this is our y-axis, and to our negative x-axis we do the same. This is negative pi, negative 2 pi, negative 3 pi, this one negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and then negative 7 pi over 2. Now let's start using the table of values. Let's begin from pi over 2 here, then pi, 3 pi over 2, then 2 pi, 5 pi over 2, then 3 pi, 7 pi over 2. Then towards the negative, I will include the 0 as well, the origin. Then negative 5 pi over 2, and next negative pi, negative 3 pi over 2. We can continue to negative 2 pi, so on and so forth. Okay, now if our x is pi over 2, let's look at here. If our x is pi over 2, what is our cosine? What is our sine? Our cosine is 0, our sine is 1. So the value of this is 1. If our x is pi, okay, the sine is 0. If our x is 3 pi over 2, where is 3 pi over 2? Okay, 3 pi over 2, our y is negative 1. Okay, let's put it over here. If our x is 2 pi, okay, that's all over here, our y is 0. Okay, 5 pi over 2, you move it here, our y is 1. Then 3 pi, that is 1 pi, 2 pi, 3 pi. Right here, our x is our y is 0, and then going here, negative 1. And for the angle 0, okay, our sine is 0. Okay, for negative pi over 2, we go to the opposite direction of rotation. So negative pi over 2 is over here, our y is negative, or sine is negative 1. For negative pi over here, our sine is 0. For negative 3 pi over 2, our sine is 1. And then negative 2 pi, our sine is 0. We continue it, and we get the same pattern. Now let's start graphing it. Let's start from pi over 2. Say this is our, say if this is our 1 here, and this is our negative 1 here. Okay, pi over 2, our y is 1. At 0, our y is 0. When x is pi, y is 0. When x is 3 pi over 2, our x is negative 1. When x is 2 pi, or x is 0, y is 0, x is 5 pi over 2. Okay, we have 1, and then 0, and then negative 1. Okay, next, we can now plot the curve like this. Okay, so we have a smooth curve, which is called sine wave. All right, and we can continue to negative x-axis, negative pi over 2. We have negative 1, negative pi, 0. Then it's 1 for negative 3 pi over 2. And then 2 pi, back to 0. And then it continues the same pattern. It's periodic. So let's continue graphing it with a smooth curve. Okay, let's continue our sine uh, sine wave. Okay, it's gonna be like that. So we have the idea already of how it looks like. Now, if in case that your function is given y equals to sine x, then you have a constant here, say for example 3, then that means the graph of that is simply like this. Now here, we translate our sine to 3 units up. So 1, 2, 3. This is now this is now this point here of our sine function. Okay, we'll see this is 3, and then this is 4 here. So the length of our sine function is 1. So it's going to be like this. So you just simply translate the sine wave 3 units up. If you minus it, so you're going to move units down from the origin. Now, if the function is given like this, y equals to, say for example, 2 sine x, then the graph would be graph would change. So how does it look like? It's gonna be like this. Now it's the same. It's still intercept with 0 or the origin, but this time the length of your y will increase by 2. Okay, because if you have sine of multiple of pi over 2, then this becomes 1, and 1 times 2, so your maximum is 2. So your graph will be like this. This is 2 here, negative 2, graph will be like this. Okay, so the amplitude will be longer compared to the original one. So if you have 3 here, it could be 3 more longer, and then if you have 5 more longer from the original one. So that's the idea of the sine function.